So let us start this program with an invocation, and I invite Gautam for the invocation.
Hello, ma'am. Am I audible?
Yes, you are audible, please.
Yes. Asato ma sadgamaya tamaso ma jyotirgamaya mrityurma Om Shanti Shanti.
Okay. Thank you, Gautam, for that invocation. Now let us pass on to the next welcome address. I invite Dr. Suresh Babu V, Principal College of Engineering, Trivandrum, for delivering the welcome address. Sir, over to you, sir.
Okay, good evening, all. Honorable Minister for Higher Education and Social Justice, Dr. R. Bindu ma'am, respected Director of Technical Education, Dr. Baijubai TP, respected Professor Veeraragavan, former Professor of IIT Madras, Head of the Department of Civil Engineering, Dr. Anil R., the coordinators of this FDP, Dr. Ashaleda and Professor Thushara V T, faculty colleagues, and dear participants. This is a cherished moment to see that the first adult FDP on design and production of reclaimed asphalt pavement mixtures, a step towards sustainable green pavement, is happening in this institution. This is a highly demanding FDP in which we are not able to admit all the applicants, contrary to the usual practice in which we struggle to get minimum required participants. This FDP is characterized by its broad range of participation from industry, academic institutions, practicing engineers, and researchers across the country. This is a well-planned and well-organized FDP with a carefully framed objectives, contents, and resource persons. The coordinators have taken a lot of efforts in applying for the FDP, getting its approval, and designing it in a nice manner to cater the need of the time. Congratulations, Dr. Ashaleda and Professor Thushara. It addresses the needs of practicing professionals, academicians, and researchers, at the same time addressing the economic and environmental issues. I believe that this program will empower the participants with the technology solutions and network with the peers in the domain. The coordinators have taken care to pick the best resource person available nationally and internationally. I hope the discussion in these sessions will lead to evolution of optimum solution for reclaimed asphalt pavements, including the protocols for its use. I wish a great learning experience to the participants and fruitful outcome for the nation through this FDP. Honorable Minister has consented to spare her valuable time in inaugurating this FDP. Her attitude towards the academics is highly inspiring. She always accepts proposals for the betterment of the academics of the institution. On behalf of the coordinators and CET, I cordially welcome you, ma'am, to the inaugural session of this FDP. Our Director of Technical Education is always supportive in all activities of this institution. Welcome you, ma'am, to this FDP. Dr. Veeraragavan, former professor of IIT Madras, has long association with the CET and technical education in Kerala. I welcome you, sir, to this function. The success of any FDP is the active participation, the interactions, and the networking out of it. I hope this will be a great experience to everyone of the participants. I welcome you all to this FDP. I also welcome the coordinators, Dr. Ashaleda, Professor Thushara, the head of the department, Dr. Anil R., and all faculty colleagues and student volunteers to the program. Thank you. Thank you all.
Thank you so much, sir. And now let me invite our Director of Technical Education, Dr. Baijubai, Madam, to deliver the presidential address. Over to you, Madam.
Am I audible?
Yes.
Madam, you are audible.
Respected Minister for Higher Education and Social Justice, Dr. R. Bindu ma'am, respected Professor Veeraragavan sir, other distinguished guests, Principal Dr. Suresh Babu, FDP coordinators, Dr. Ashalada and Professor Thushara, and participants of FDP, staff and students of CET, and dear friends. It's a great honor for me to attend the inaugural session of ATAL FDP of Civil Department of CET today. The main objective of extending support to technical institutions in fostering research and innovation through training in various emerging areas, AICTE introduced ATAL FDP in 2019. This program is very well accepted across the country, and thousands of programs on emerging technology are being conducted every year. And we all know that ATAL Academy has been conferred awards by World Book of Records for their contribution to the faculty development. And we can see in the listed ATAL FDP courses or programs of Southwest region of AICTE, the only one program selected from government engineering colleges is from CET only. And I appreciate the principal, the coordinators, and the staff of Civil Department in their initiatives. And during the 14th five-year plan, one of the critical gaps we identified in technical education is the insufficient industrial exposure for the faculty members. By organizing such faculty development programs, faculty members are getting a chance to update their knowledge at par with the industry standards. And today, we are very fortunate to have our Honorable Minister, who is very keen in the reforms of higher education Kerala, to inaugurate this 2 weeks long FDP program. Madam has initiated many steps towards enhancing the quality of higher education, and engaging 3 commissions for academic reforms, administrative reforms, and examination reforms. These are one among them. And by implementing the commission suggestions, definitely higher education of Kerala state can attain top levels as envisaged by our Honorable Minister. And today we are all waiting for the encouraging words from our Honorable Minister. And also, before concluding, let me say that great academicians and distinguished experts from the industry, they are engaging the sessions of this program, and definitely this FDP will be a great benefit for the participants. Also, this FDP provides a platform for the participants to upgrade their knowledge of reclaimed pavement mixtures. And I wish all success for this program, and I invite our Honorable Minister for the inaugural speech. Thank you.
Am I audible?
Yes,
Yes,
madam.
ma'am. Yes, ma'am.
Yeah. Respected chair of the session, Dr. Baijubai TP. Respected resource persons, Principal Dr. Suresh Babu, Dr. Ashalada, the course coordinator, dear participants of this FDP, and other friends. At the very outset, let me extend Very warm greetings to all of you on behalf of the Higher Education Department of Kerala. Let me wholeheartedly congratulate the Department of Civil Engineering, the College of Engineering Trivandrum, for bagging an opportunity to conduct an FDP program in relation to AICTE-ATAL project. Let the seminar be fruitful in radiating the brilliance of updated knowledge in the age of speedy technological advancement. We in Kerala are keenly concerned with knowledge translation today, tracing the ways in which theoretical knowledge and research activities should be extended beyond the walls of laboratories and college campuses. How new knowledges produced through innovative researches could be taken from the ivory towers of academic discourses to a larger world of social praxis, real practice. How new knowledges and innovative practices could effectively be used to enhance the standard of living of our people. How new technologies can be assimilated or amalgamated with the process called development without harming the environment. This is the crucial question addressed by the Higher Education Department of Kerala today. The relation between environment and development has at best been one of dissonance that is not easily resolved in spite of decades of our nursing the notion of sustainability. Human society needs development, but the development facilitated by science and technology has notoriously harmed the environment and systematically threatened human existence itself. In a not so distant scientific dystopia, the last remnants of human life as we know it might be wiped out, replacing it with life forms that may have greater capacity to survive in the hostile landscape that development has created. The greatest human effort now is the attempt to escape this dire predicament. Environmental stewardship or active participation in conservation efforts alone can be considered as a responsible form of development that keeps degradation of environment in check without harming the prospects of human progress. In education, planning, policy making, and a lot many other human activities, this proactive conservation becomes the order of the day. Recycling is an integral part of this process. Infrastructure is one of the most significant aspects of development, and transportation, whether in the form of roads or railways, is an inevitable part of the process. Any country that intends to develop should build a network of roads facilitating human as well as good traffic with minimum effort and maximum speed. In the modern world, connectedness is the internal dynamics that sustains human society. It goes without saying that we have to constantly explore more and more cost-effective methods of recycling that will reduce the waste load of the earth and make our environment cleaner and more livable. Instead of making mountains of used and discarded asphalt that remains as irreducible blots in our surroundings, we should reclaim it and use it to further strengthen our roads. The technology that the Civil Engineering Department of College of Engineering Trivandrum and AICTE-ATAL try to harness through this training program is hopefully a step towards more responsible and sustainable technology. In that sense, this program is an indicator of the future of technical education, which will have to bring about a proper marriage of sustainable technology and responsible education. Preparing our future generations to tackle the overwhelming problem of increasing waste without retarding human development is the tone we have to set for our education. It is fervently hoped that the participants of this program will glean important lessons in making recycling more cost-effective, more socially acceptable, and more futuristic, making the technology more sustainable for the local conditions and climate. This is especially important as roads are constantly exposed to climatic conditions and must get enough research that will produce materials that can withstand the onslaught of adverse weather. This program might plant new signposts for future research and thus enrich the corpus of our knowledge and make it available to the society to make life more livable around us. Wishing the seminar all the very best. Let it be a grand success. With these words, thanking you all, I conclude. Best wishes.
Thank you, ma'am.
Thank you. Thank you, madam. We thank you immensely for finding time out of your very busy schedule and for coming online and for inaugurating this FDP and also for a thought-provoking speech. And your presence indeed is a motivation for all of us here. Thank you, ma'am. Thank you.
Okay.
Now let me invite Dr. Ashalada, the course coordinator, to speak about this course. Over to you, ma'am.
A very good evening to all of you. Honorable Minister of Higher Education and Social Justice, Dr. Bindu Madam, respected Director of Technical Education, Dr. Baijubai Madam, Principal, Dr. V. Suresh Babu Sir, Head of the Department of Civil Engineering, Dr. Anil, Professor Veeraragavan Sir, Professor retired from IIT Madras, Dean of College of Engineering Trivandrum, HODs of various departments, and dear participants who are joined from various parts of India, faculty members of Department of Civil Engineering, and dear student friends. It is indeed a moment of pride for CET, especially Department of Civil Engineering, for having the AICTE-ATAL proposals being selected, which actually went through a very tough competition at national level. The repute of the institute, like its NIRF ranking, the importance of the topic, the strength of the CV of the coordinators all played a significant part in the course getting selected. And it is a moral boost to the institute and all of us here. And this idea, the very idea of applying for such a course at the national level, that came from our former head of the department, Dr. Unnikrishnan, who motivated us to explore the possibility. And then we thought of submitting a proposal on this design and production of reclaimed asphalt pavement mixtures, as it is going to be the future technology, or it's going to revolutionize the pavement construction, leading to saving of virgin material, both bitumen and aggregate. And we got tremendous support in talking out the course schedule, identifying the topics, getting good speakers from Dr. Murali Krishnan, Professor IIT Madras, and we are also deeply indebted to Dr. Veeraragavan Sir, who has been, as Principal Sir was saying, has long association with College of Engineering Trivandrum, and Sir has extended all support, full support indeed, and for also agreeing to deliver the keynote address today. And we are also fortunate to get eminent speakers from premier institutes, or we have 6 speakers from 6 different IITs, IIT Madras, Delhi, Guwahati, Kanpur, Kharagpur, etc. As well as we have got speakers from internationally reputed consultancies, and also from our own research centers like NATPAC and KHRI. Altogether, we have 16 speakers. And as Principal Sir was mentioning, it is for the first time I have conducted many courses, but it is for the first time that we found it very difficult to accommodate the request of all the participants. And once we uploaded the brochure in the AICTE site, in the second day itself, we got 35 participants from outside the state. And since AICTE has made it mandatory that the participants should attend both online, because this is conducted in a hybrid mode. We have 1 week starting from today online and the next week offline. So AICTE has made it mandatory that the participants should attend both the sessions. So because of that, we had to eliminate those who couldn't travel down south. But because of the continuous request, we are sharing the link to attend the online sessions. So, and the maximum limit for the online participation is 50. So we also have 50 participants. Of that, 16 are from outside state, 13 faculty members from within the state, 13 participating from the industry, and we have 90 research scholars from premier institutes. And also we have representatives of state policy makers like KIFBI, and also we have participants from various state universities, NITs, CRRI, and for research wing of LNT and Veeraragavan. And as I said earlier, AICTE-ATAL program is conducted in hybrid mode. And from 9 to 14th, we have these online sessions. We also have experts joining from US. We have 2 experts joining from US. And in addition to these expert lectures, it is mandatory in this course that we have to take them to the premier research labs within the state. And so the participants will be visiting the laboratories of KHRA and NATPAC on 18th. And there will be discussion on important research papers. The participants will be divided into various teams of 5, consisting of 5 to 6 members. And there will be a continuous evaluation of the participants also. We also arrange a 1-hour talk on stress management by an AICTE approved agency on 18th Wednesday, that is from 9:30 to 10:30. And attendance, AICTE has made it mandatory that the participants should have 80% attendance, and they'll also have to submit a report after the industrial visit. So this is all about this course. And I wish once the participants attend this two-week course, they become completely enlightened in this very important topic, which is of national interest, because our quarries are depleting. We can no longer use these aggregates and bitumen assets. We have to see how we can be reclaimed. And even the World Bank will be insisting on using almost 100% of the reclaimed asphalt. So we'll have to find out what are the gaps in the research. So this is a very important topic. So I hope that once they attend these courses, they'll be able to take up quality research works. And I wish all the participants the very best, a very fruitful stay in Trivandrum next week, and also and a very enlightened course. Thank you. Thank you all. Okay. Hello. So next, let me invite Professor Thushara, one of the co-coordinators, to propose a vote of thanks. Over to you, Thushara.
Am I audible? Good evening to all who have joined this online session. At the outset, let me express my vote of thanks to all who has put their effort to make this course a reality. On behalf of College of Engineering Trivandrum, let me extend a special thanks to our chief guest, Honorable Minister of Higher Education and Social Justice, Dr. R. Bindu, for accepting our invitation and to join us for inaugurating this session in spite of her busy schedule. Ma'am, your thoughts related to sustainability is a real inspiration for us to carry out more research in this area and to bring out new technologies in practice. Let me also extend my sincere gratitude to the Director of Technical Education, Dr. Baiju Bai, to join us and to preside over the function. Our principal, Dr. Suresh Babu, has always been a support to conduct such courses, which provide a platform to disseminate the expertise we gain to a wider group. Let me thank him for all support and guidance. Let me thank Dr. A. Veeraragavan, former Professor IIT Madras, for his guidance. He will be delivering the keynote address for this course after this inauguration session and will deliver his vast expertise in this area. I take this opportunity to extend sincere thanks to our current head of department, Dr. Anil, for his constant support, and our former HOD, Dr. Unikrishnan, who has triggered us to formulate the proposal for this course. It is now time to express sincere thanks to all the experts from the transportation fraternity. We have approached 16 experts who are specifically working in this domain of this course, and all of them has readily accepted our invitation to deliver expert talks during this program. This itself became a real motivation for us. Now, the response from the participants was also encouraging and underlined the prominence of this area where there is a lot of scope for the research activities. Let me take this opportunity to thank all the participants who have joined here. I am sure that the wide spectra of the participants will help us to push the new technologies for the sustainable development of the session of the country. Thank you.
Thank you, Thushara.
Okay, thank you all.
Okay, with that, we come to the end of the inaugural session, and I request the participants to stay back. We'll have the technical session starting at 7:30. We'll start at 7:30. It starts with the keynote address and also interaction with Professor A. Veeraragavan. Thank you all.
Thank you.
Thushara, are you able to see the full screen?
Yes, sir. Yes, sir.
That day we had a problem. That's why I was not sure.
Yes, sir. It is.
Now it's full screen, right?
Yes, sir.
Okay.
So we'll start the session. So let me briefly introduce our keynote speaker, Professor Dr. A. Veeraragavan. Professor Dr. A. Veeraragavan, sir, is a retired professor of civil engineering from IIT Madras, and he retired in the year 2021. He has over 42 years of experience in teaching, research, and industry consultancy. Professor Veeraragavan received the Indian Roads Congress Pandit Jawaharlal Nehru Awards in 1994 for his outstanding contribution in the field of highway engineering, Indian Roads Congress medals for his best papers in the years 1991, 93, 97 to 2004, 2008, 12, and 22. He has also received IRC commendation certificates for his highly commended papers in the years 92, 94, 98, 2000, and 2015. Professor Veeraragavan is a recipient of the UGC Career Award for Young Teachers and National Award for Promising Engineering College Teacher in India from the Indian Society of Technical Education. He received the Vishwakarma Award under the category Outstanding Academician, Technologist, Scientist, Innovator from the Construction Industry Development Council, Bhagyalakshmi Krishna Iyengar Award from IIT Madras for having guided the best MTech project in infrastructure engineering. He received the award for distinguished services to IIT Madras from the IIT Madras Alumni Association. He has also received the Plaque of Honor in recognition of his outstanding achievements to academics and research in the field of civil engineering by Riva University, Bangalore. He is a member of the National Panel of Experts constituted by MORTH, Government of India, to implement value engineering program to promote the use of new technologies, materials, equipments in highway projects. Professor Veeraragavan has published over 250 research papers in national as well as international journals and conference proceedings. He has coordinated over 15 major research projects with a budget of over 12 crores. He has co-authored 5 technical books on surveying, highway engineering, highway materials and pavement testing, pavement drainage, theory and practice, and bituminous road construction in India. He is a fellow of the Institution of Engineers and fellow of International Society of Engineering Asset Management, life member of the Interroads Congress and the Institute of Urban Transport. He is a member of the IRC Technical Committee on Highway Specification and Standards, Flexible Pavement and Airfield Runways, Composite Pavement, Rigid Pavement, Road Maintenance and Assess Management. He is a member of the Expert Working Group constituted by the IRC for the revision of mode specification for roads and bridge works. He is the chairman of the Research Proposal Evaluation Committee of National Rural Infrastructure Development Agency, Government of India. He is the chairman and BOG Board of Governing Member of the TechU Program of Government Engineering College, Idiki. He is also an independent director of L&T IDPL board and the 3 SPVs. He is a member of the editorial board of many national as well as international journals. He is a member of the technical committee of Karnataka Road Development Corporation Limited and technical advisor to RASTA, the Center for Road Technology at Bangalore. So we are indeed honored to have you, sir, for the keynote address. Over to you, sir.
Thank you, Thushara. At the outset, let me thank Dr. Ashalata and Mrs. Thushara for inviting me to deliver a talk on the in the FTP on the design and production of reclaimed asphalt pavement mixtures, a step towards a sustainable green pavement. So there are many stalwarts for delivering lectures in this course. I do not know whether I am eligible to deliver the keynote address, but nevertheless, I thought that I can deliver a talk. I would not call it as a keynote lecture, but I would like to deliver a talk with my thoughts and what you are expected to do as a research work in the years to come. I find this audience consists of both students, research scholars, faculty members, as well as practicing engineers. More or less, I have been successful as a practicing engineer rather than as a teacher. So I would like to take you towards the practice point of view so that you can link theory to practice. You will be taught lectures on the binder characterization, mixture characterization, the modulus determination, modeling of the performance on one hand, vis-a-vis construction, quality control, and other aspects. Let me try to bridge between the theory and practice while I take you over to some of the slides, through these slides, on the use of reclaimed asphalt mixtures for rehabilitation of pavements, what are the issues and challenges. So if you look at this, why do you need to reclaim the pavement? As you know, any pavement for that matter, you will design for a design life of 15 years or 20 years. What is the design life? A design life is one, a pavement should not warrant a major rehabilitation. But how are they performing? None of the pavements in India constructed in the last several decades do not function for the entire design life. They deteriorate with the traffic load repetitions. They deteriorate due to aging. Of late, what we have introduced is a performance-based maintenance in many of the BOT projects. Pavements, whatever we try to do, whatever may be the material that you want to use, it may be any material under the earth. But even you use the best material that is possible, the pavement will eventually deteriorate. Once it deteriorates, it warrants maintenance. These maintenance can be in the form of a routine maintenance, which includes crack sealing, pothole patching. It can be shoulder dressing, drain desilting, which can be done day in and day out. But there will be a reduction in the performance because of the deterioration. It will warrant a resurfacing. The resurfacing is mainly a functional requirement to improve the rating quality. Even though you do the resurfacing, a pavement will warrant strengthening because the pavement layer materials will undergo deterioration. So this I call by the term rehabilitation, a major rehabilitation, wherein the thickness is more than 40 millimeter. The question arises at this point of time, can this reclaimed asphalt pavement mixtures be used for improvement of the functional quality, or the improvement of the structural quality, or both? What are the issues and concerns here? The major question that anybody will ask is that if I use a conventional bituminous mix vis-a-vis a bituminous mix with wrap, will performance of both be the same? Will a wrap mix perform better than a virgin mix? What are the issues and concerns? So on theory or in the laboratory, it is easy to do a mix design with 5, 10, 15, 25, 100 kg of material. But we produce 100 tons per hour, 200 tons per hour in the field. So will the laboratory test be able to simulate the field condition, the field performance? That's the $1 million question. We require a huge quantity of aggregates. For example, if you want to provide just 40 millimeter bituminous concrete, it requires nearly 875 cubic meter per kilometer for a 4-lane highway. This goes up to 1785 cubic meter per kilometer of a 6-lane highway. Now we have nearly 63 lakh kilometers of roads in the country. Nearly 1 lakh kilometers of 4 and 6 lanes. We have empowered construction of expressways. The major problem that we face in India is non-availability of good quality aggregates. Therefore, the mantra that has to be practiced in the years to come is reduce the consumption of the virgin aggregate, recycle the material that has already been constructed and reuse them. And there comes the necessity of this FTP, wherein the faculty members are trained with the hope that you will in turn train your students, as well as the practicing engineers will also practice wrap mixes in their projects. As you know, a pavement condition will deteriorate with age. Initially, a preventive maintenance will work. A preventive maintenance will only delay or retard the rate of deterioration of the pavement. That is can be done when the pavement is in a good structural condition. But once it reaches some more deterioration or attains some more deterioration, it will warrant a minor rehabilitation. Minor in the sense, the thickness of the overlay or the treatment will be less than 40 millimeter. Generally, it can be 25, 30, or 40, or it can be even lower. Furthermore, when the pavements are deteriorating, it will warrant a major rehabilitation. But the time is money. Once you try to do the maintenance much earlier than life, the cost may be, if it is $1, it will warrant, cost will go up to 5 to 10 times more the more and more you delay. The question arises at this point of time, what is the time for the rehabilitation of the pavement with a reclaimed material? That's the question. So here, when you look at this, you find that, when you look at this, the pavement will warrant a recycling at this point of time. Can you do it here? Can you do it here? These are other questions that have to be answered. Can you do it earlier? It can be done anytime, depending upon the distress. So any pavement material that has deteriorated can be recycled and reused. If you do it much earlier in the life, maybe the top bituminous layer alone may have to be rehabilitated. Once you delay it more, along with the wearing course, the binder course may also to be recycled. Once you delay it further, you may have to go to the lower layers of the wearing course, binder course, and the base course. So there are different types of recycling. Depending upon the time for the maintenance and rehabilitation, the type of recycling to be adopted will also vary. When the pavement has totally failed, can it be again reclaimed? Yes, that is possible. We can go in for a full depth reclamation. For your information, nearly 5,000 kilometers of rural roads are being reconstructed using a full depth reclamation. Will it perform similar to that of a new pavement? There are issues and concerns here. So what are the reasons for rehabilitation? Number one, there can be an inadequacy in the riding quality. So generally what we do is when the riding quality becomes poor, we provide a thin overlay. But now, remember I told the beginning itself, we require more than 1,000 cubic meter of material for construction of 1 kilometer of a 6-lane highway resurfacing with 40 millimeter. So if I want to reduce the consumption, can recycling be adopted? Yes, of course. Or when there are excessive distresses in a pavement, again, rehabilitation is warranted. Say, for example, in some places, there is a problem of skid resistance, low skid resistance. Can I recycle the material to improve skid resistance? Of course, possible. A pavement, I have been rehabilitating the pavement again and again and again, but it is still failing. So in such cases, the problem can be with the binder course. The problem may be with the base course. The problem can also be with the sub-base course. In such cases, can I go for rehabilitation? Yes, of course. If the user cost becomes more, rehabilitation may be another alternative. Supposing the payment, single lane payment may have to change into 2-lane or 2-lane to 4-lane, 4-lane to 6-lane. In that case, will I be able to recycle the material, use it in the case of 6-laning? Yes, of course, we can do that. Therefore, rehabilitation can be adopted as and when a pavement deteriorates or in the case of upgradation of a highway as well. But here, what I said in the beginning, if you recall, depending upon the timing of the maintenance treatment, that there are different choices for the recycling. This recycling can be done in situ, which I call with the term hot in-place recycling, or it can be the milled material can be taken to a central plant. It can be a hot central plant recycling. It can similarly, we can also go in for coal mix, which can be coal mix in place, or coal mix can be in a central plant. Eventually, when the entire layer have deteriorated, I can also go in for a full depth reclamation. So what you should learn is that which treatment will work under what condition, how to do the mix design, will the reclaimed pavement perform similar or better than a virgin or new design. The selecting the recycling method becomes the major issue. So there are several considerations that are to be done. Number one, the choice of the recycling depends upon the type of distress. I'll show you a few photographs that will enable you to understand how the type of distress dictate the recycling technique that has to be adopted. Second, you have to consider the engineering aspects. Third, economics. So what you understand from this is that before you embark on recycling as the recommended maintenance or rehabilitation strategy, you should have, as an engineer, you should know what is the contribution for the different distresses. Which are the layers that have deteriorated? Is it technically possible to do the recycling? And what are the cost economics? If you look at the distresses in a pavement, it can be a surface distress. It can be a case of deformation. It can be rutting, slippage, corrugations. It can be cracking. Cracking can be this cracking can be a case of a load associated cracking, non-load associated cracking, or reflective cracking. And there can also be maintenance patches. But remember, recycling is not the recommended treatment for all types of distresses. So if somebody tells that the riding quality is bad, I will recycle, need not be. I can have a cheaper alternative rehabilitation treatment. There is no one-size-fits-all design. This is where the engineering judgment comes into picture. If you look at the other aspects of the pavement, For example, there's a fatigue cracking. This is a fatigue cracking interconnector cracks. Can this pavement be recycled? Should it be recycled by a hot mix or a cold mix? Or does it warrant a full depth reclamation? That is what you should understand at this point of time. It can be a top-down cracking. Does it require an overlay? What overlay? What thickness? If I provide an overlay above this, will this crack reflect on this? Yes, of course. If so, what is the treatment? It can also be a case of a block cracking. It can be a case of rutting. It can be a case of rutting even before opening to traffic. Or it can be a bleeding. So what you understand at this point of time is that there are different distresses. There can be a treatment for each of the distresses. There is no one-size-fits-all design. Can all these be recycled? If I recycle the material and lay, will it not bleed? Will it not crack? Will it not rut? Supposing if you provide an overlay, what will be the comparative life between a conventional overlay vis-a-vis a reclaimed material overlay in the bituminous mix? What the dosage of wrap that can be added? These are the issues. Other aspects that have to be considered in the engineering are the riding quality of the pavement, type, extent and severity of the different distresses, structural capacity of the pavement, drainage conditions, age of the pavement, and the remaining service life, as well as the design life that is required. Supposing if a pavement has developed a distress because subgrade is weak, can I do a hot in-place recycling? No. Can I do a central recycling? No. Can I do a cold in-place recycling of the top layer? No. So when there are problems with the lower layers, inadequate subsurface drainage, then it warrants a different type of rehabilitation. So there is no one-size-fits-all design. At the same time, you should be able to evaluate what is the remaining service life and what is the strength of the existing pavement, and then accordingly design the wrap mixes. In addition, there can be another issues of environmental issues, material use in the existing pavement, because a pavement consists of different layers of different materials. So you have a cocktail of materials. How do you characterize a material? I am able to find in the schedule, there are experts who are talking about binder characterization, mix characterization, modeling, etc. Perhaps you can pose more questions as how do you account the various materials that are used in different layers, how to characterize them, how to predict the life. Also, when I want to do the recycling, I need materials. For example, if a coal mix, I need a foam bitumen. I need a good quality emulsion. I need an equipment. I also need an experienced contractors. Engineering consideration can be, I should know what is the maintenance history. What was the cost of maintenance? At what frequency I have carried out the recycling or maintenance. In addition, you should also consider the material transportation, mix transportation, production of the mix, as well as placement and compaction. All these each of these play a key role on the performance of the wrap mixes. In addition, the overhead clearances that are to be considered, the curves and gutters, drainage structures, shoulder, median barriers, guardrails that are there, everything has to be relocated. There will be a change in geometrics. These costs should also be considered when you want to compare the cost economics of wrap mixes. I'll just give an example of what are the issues and concern when you want to recycle a bituminous layer. The bituminous layer, as you know, consists of a wearing course, a binder course, and a base course or a lower binder course. I will call it as an upper binder course and a lower binder course. The wearing course generally consists of a modifier, consists of a bituminous concrete or a stone matrix asphalt, generally with a modified binders. So the wearing course for national highways contain a modified binder. It can be a crumb rubber modified binder or it can be polymer modified binder. Again, there are different polymers that are being added. So this polymer modified binder will not have a uniform characteristics. Depending upon the polymer added, its dosage, base bitumen that was used for the production of the modified binder, its properties will change. It's possible that The binder course, which generally we are now adopting, can be a high modulus base. The binder that is used a high modulus base or high performance base is something different from that of the conventional viscosity grade or a modified binder. If that is the requirement, now I have two different layers having two different gradation, two different binders. If you come to the lower binder course, it is supposed to take care of the fatigue. It will supposed to have a high percentage of binder to take care of the fatigue, which can be a conventional unmodified bitumen as well. So we have a modified bitumen at the top. We have a high modulus base or binder course in the middle and have an unmodified binder at the bottom. Now I want to recycle the mix. I have a binder which consists of an unmodified and modified high modulus binder. How do I characterize this? Perhaps we can pose questions. Definitely the experts will be able to clarify how to characterize this wrap binder and use it in the mix design. If come with economic aspect that are to be considered, or the traffic control during the recycling, length of the construction period, impact on just business, utility relocation and interference, and there are other financial evaluation methodologies that are to be considered, like comparison based on the initial first cost, net present value, or the annualized cost or the cost benefit, and finally the life cycle cost. So when I want to use a wrap mix, will the wrap mix perform similar to that of the virgin mix? What is the rate of deterioration of this binder, by this wrap binder mix or a wrap mix? Depending on the dosage of the wrap, the performance of this wrap binder mix will be different. So how do you predict the performance? What models? I'm sure that the experts are there to talk about the modeling. But remember, you are modeling only the bituminous layer. The performance does not depend only on the bituminous layer. The performance also depends upon the supporting layer. So do not model only the bituminous layer and call it as a pavement performance. Say binder performance, say mix performance. The pavement is something different animal. It has got a base course. The base course can be a cement treated base. It can be a bitumen treated base. It can be granular base. The sub base can be a granular material. It can be even a cement treated sub base. The subgrade can be conventional granular subgrade, or it can be a stabilized subgrade. So keeping the top bituminous layer constant, you cannot predict its performance and say the pavement will perform. You can say mix will perform. I don't question that. But when you talk about the pavement performance, you have to consider the supporting underlying layers as well. So we have to evaluate the effectiveness of this treatment so that we can adopt this in the years to come. So if you look at the hot mix recycling central plant, you can adopt it when there are surface defects, deformations, cracks, or maintenance patching. So but the percentage of wrap in a central plant depends upon the recycled mix properties as well as the type of the plant. So again, you may do a laboratory mix design. You can have 100% wrap as well. But will that be possible for you to mix in a plant? That's the question. So the designer should also consider the consideration of the plant and its limitation and accordingly design. You have to cut the leg to the shoe size. Depending on the plant capabilities, you have to design the mix. It can also do an in-place recycling. Supposing there are only surface defects, poor rating quality, surface cracks, top-down cracks, corrugations. In such cases, definitely you can go in for hot in-place recycling. Sufficient amount of workspace is required. If the equipment trained, it heats the surface, it mills the surface, there's a pug mill, it mixes, you add some virgin mix, relay it again. So it can also use a rejuvenator in that case. In the case of coal recycling, it can be central plant, we can go down below. Here's the problem with the base course. You can mill up to the base course. But when you do a coal recycling, a wearing course is generally required because this mix will have higher voids, is expected to fail in rutting, not in cracking. It can also do for coal in-place recycling, wherein the problem of rutting in a subbase is there are load associated cracks. You can go for coal in-place recycling. It also requires curing period. It also warrants a wearing surface. So I can go for hot recycling or a cold recycling. Depending upon the plant availability, I have to decide what type of mix recycling I can adopt in situ, or it can be a central plant. So there are advantages or limitations for each of this. I'm sure when you are discussing about the mix design, you can understand how to link the mix design with the plant capabilities. I can also go for full depth reclamation, wherein either a problem in the sub-base, we can go our sub-base course or wearing course, we can go in for a full depth reclamation. This is what we have embarked now in UP. Nearly 5,000 kilometers of UP roads are being reconstructed by the full depth reclamation technique using different stabilizers. I do not know how far they will work. There are no guidelines in India, but we have gone ahead with the full depth reclamation. Will it crack? Will it not crack? Do you need a crack leading layer or not? Nothing is known. So we are just embarking upon this, but so maybe that subsequently we'll be able to tell whether this FDR can be adopted even for national highways. So what are the common barriers here? The common barriers when I want to use a wrap mix is quality concern. Will it function better or similar to that of a virgin mix? Second, I get a wrap. Will I bring some sample to the laboratory and do a mix design? Is this sample which I'm testing in the laboratory is exactly what I will get in the field or not? If there is a change in the mix wrap gradation, how will it influence the performance? There is a lecture also on the variability on wrap and its performance. Perhaps we can discuss further. Binder grade and its grading and its blending, how do you mix it? Third, do you need a rejuvenator? Will a rejuvenate function to modify the binder properties? How do you calculate the effectiveness? When you want to do mix design, what are the issues in material, gradation, procedure for the mix design, as well as the volumetric requirements? What are the issues and concerns? Will this wrap mix have a higher durability? It's supposed to have an aged binder. Will it crack? Especially when you want to have 40–50% wrap mixes, how is it likely to perform? I can show some cases as how it has performed, which will make you to think twice before you adopt wrap mixes. Supposing when I have adopted modified binders, especially in all wearing courses, in all national highways, we recommend usage of a modified binder. This modified binder can be a crumb rubber modified binder. It can be a polymer modified binder. Again, there are different polymers that are added. So when you want to have a binder in a wrap mix, consists of different polymers, how to characterize that binder? I'm sure that the talk on the binder characterization will address this issue. I may also have a stone matrix asphalt wearing course. I can have a stone matrix asphalt binder course as well. Suppose if I mill the top 75 millimeter, it consists of a wearing course, which is again SMA, a binder course, which is also SMA. How do I consider this wrap mix of SMA, which also consists of cellulose fibers? Is it practically possible to separate them out? Can I have it in the mix? How will the mix perform? Finally, the proof of the pudding is in the eating. When you transfer lab to the field, you should consider the variability in the material, construction process, and as well as the construction quality. What are the issues related, material related issues? What is the degree of mixing that will obtain when placing a recycled mix on the road? This is the first question that has to be answered. But when you look at the degree of mixing, it depends upon the mixing temperature. As you know very well, the mixing, laying, compaction temperature vary depending upon the type of binder that you use. Even between unmodified binder, whether it's VG30 or a VG40, there is a variation in the mixing, laying, compaction temperature. When you use a polymer modified binder, the manufacturer recommends the mixing, laying, compaction temperatures depending upon the properties of the modified binder. Now, I have a binder which is neither modified nor unmodified. It's a combination of both. So theoretically, the laboratory can do that, but when you want to go to the field, what I found is that there are different types of polymers that are used in some of the road projects. You name any supplier, he has supplied a modified binder. In a stretch of 240 kilometers, which I studied, at least there will be 10 to 15 different suppliers of the modified binders, different polymers. It can be polymer, but different polymers, different dosages. So I may do a sample, 5 samples, 10 samples. Will these 10 samples represent the entire pavement section is the question. How do you characterize the reclaimed material? How do you consider the production method? So the quality of recycled mix, recycled binder includes consistency, aging properties, structural stability. They're all related to the chemical constitution of the whole binder. So is the base binder same in all cases? No, I do not know what is the base binder that was used in the polymer modified binder. What I will get tomorrow also I do not know. The refinery person also may not know. They get some crude, they process it, modify it so long as meets the BIS specification. We feel is okay, but the performance depends upon many other parameters which are beyond the scope. I can add a rejuvenator. When I add a rejuvenator, which is try to rejuvenate the binder, will it become like a virgin binder? That's another question that has to be answered. So choice of the rejuvenator, again, there are different types of rejuvenators. How do you choose? How do you know if you go to this plant and see, or go to a construction site and see, the rejuvenator is sprayed. Once you spray the rejuvenator on a reclaimed material, will it try to modify the property of the bitumen coated aggregate? That's the question. So bitumen structural stability may be of special interest because there are 2 binders, they are mixed, which influence the interaction between the compounds, the stability of the recycled binder. So a lot more need to be done as the material related issues. Rejuvenator, when they want to talk about the diffusion of the rejuvenator, they have studied using FTIR to characterize the bitumen, rejuvenate diffusion, but what they found is that there's lack of understanding of the diffusion process, interpretation of the limited lab results. What at the most you can do is bring some material in the laboratory, carry out some laboratory studies. The question, $1 million question is that, will a rejuvenator diffuse into the bitumen and modify its properties? A wide range of rejuvenators are available in the market. Everyone will say that his rejuvenator is the best. But how do you decide the compatible rejuvenator? Perhaps the lecture will be able to learn rejuvenator or characterizing the wrap binder. You will get more understanding of how to decide the compatible rejuvenator. Third, how do you characterize the properties of the aged binder? Again, it consists of modified as well as unmodified binder. Each property depending upon the age, and when you add a rejuvenator, the amount of diffusion also matters. So finally, what I would suggest is that go to the field from any site where they have constructed the reclaimed material. Bring back the lab and check whether there is a diffusion of the extract by extracting the binder, check how much it has diffused. Long-term performance of the rejuvenated material is under tropical climate is something that needs to be studied further. Other issues that are to be addressed are the volumetric properties. The percentage of wrap in a mix depends upon contribution of the wrap in the total mix. Also, the percentage of binder in the mix by weight. Second, it also depends upon the binder grade. There will be a stiffening effect of the aged binder. So will the aged binder, stiff binder, become soft by adding a rejuvenator, or maybe a case of a softer grade of binder? We use generally a blending chart. So is blending chart the only solution? Definitely a lecture on the characterization of the mixes will tell you as how to find the suitable grading of the binder, suitable grading for the aggregate, so that the finished product will perform similar or better than a virgin mix. The issue comes in this point of time on sampling. Sampling involves taking a random sample. So if you go to a stockpile, if you go to a stockpile, you can find that the aggregates that are segregated here. If there are too much of fines here. So if you take a sample here and characterize it, it will have a different properties. If you characterize this, it will have a different properties. In the laboratory, at the most, how many you can do? 5, 10, 15. But you imagine the quantity of material that's being recycled at the site. What percentage of the RAP mix do you study in the lab? Will you be able to predict the field variability? That's another question. Test individual samples, check the gradation variability. So this sampling test frequency depends upon the amount of RAP used in the mixture. For example, when I want to mill the material, I may be milling a material constructed 20 years back. I do not know the source of the aggregate. But today, I consider that aggregate and the aggregate I'm getting today to behave similarly. There will be a variation in the gradation properties. Similarly, other challenge will be to find out the bulk specific gravity of the RAP aggregates. So this RAP and virgin aggregates specific gravity is bulk specific gravity is needed in the volumetric calculations. So the aggregates will contain small amount of unextractable binder. There will be issue of wettability, water absorption. Therefore, be careful when you work out the volumetrics of the RAP mixes. The binder content, how do you find the binder content? I can find the binder content either by solvent, using a solvent extraction, or by ignition oven. But do they give the similar result? Binder content. Some fines will always flow through the centrifuge. That means you have to do the second centrifuge usage to extract only the binder and characterize it. There is a wide variability in the PG grade of extracted and recovered binder. Large amplitude shear tests indicate RAP binders varies based on the source. How do you account the source variability? Perhaps we can ask this question to the faculty who will be delivering a talk on binder characterization. So aggregate specific gravity of the RAP stockpiles are consistently lower than that of the RAP mix. The finding of the specific gravity of the RAP aggregate, each will yield mixtures with different volumetric properties. This is the experience from Massachusetts. Stockpile may have RAP from different properties. How do you account this variability? The blended binder predicted by Asher blending equations is not fully accurate. If so, how do you blend the binder grade, blend a binder grade characterization? So it also, this binder will have a profound effect on the mixture air voids. Therefore, even though theoretically speaking, both are mixed design, virgin mixed design, RAP mixed design, the process remains the same, but materials are different, binders are different, and hence the performance will also be different. So stiffer RAP shows an increased air voids that will influence your routing properties. They found that RAP source, virgin binder source, percentage of RAP, they had a significant effect on the performance. Be careful when you want to characterize these properties. So we also need the lack of possible criteria, which precluded exactly which mixtures are balanced, which mixtures are unbalanced. So there are some variables. Will it work at low, medium, or intermediate temperature? We test at one temperature, rating at 60 degrees, tracking maybe at 25 degrees. How will it perform at the intermediate temperature? Low temperature, this is some question that you have to understand when you want to characterize a RAP mixture. So assumption of 100% blending between RAP is inaccurate. Once you vary the dosages from 10, 20, 30, 40, 50, you'll find the mixtures behave differently. Degree of blending is a function of RAP content, the source, as well as its properties. Just imagine a case of material variability. They have taken samples from different stockpiles, A, B, C, and D. Some of them are uncrushed, and some of them crushed. You find that wide variation in the 35 micron POSIX that will contain higher percentage of binder. That will dictate your binder content determination as well as performance. How does it influence? If you look at this variability, assume that I have 40% RAP. you'll find that there's a wide variation in the performance. The top line is the longitudinal cracking. The pink line is the alligator cracking. You'll find that the rutting is by the black line. You find that as the dosage of the wrap increases, the performance widely vary. Therefore, be careful when you talk about a high wrap content. If you look at the assumptions, complete blending is found to occur between virgin and binder. Is it true? You have to ask this question. The amount of blending is somewhere between complete blending with no blending. How do you find it? For the lab blending to the field. In the lab, you can do anything, but the field is different. Will rejuvenator really modify the binder properties? There is no method to determine the amount of blending that occurs in the field. You can bring a sample and check later. That's post-mortem. Suppose you find the dynamic modulus. Does it tell about the proper blending has occurred by using the mixture properties? So findings that we are making tall claims are based on laboratory studies. You find out the field variability and then fine-tune your findings. Blending charts are used. If blending charts are used, it's time consuming. You have to extract the binder. You have to use it using hazardous solvent. Is that the method? Many agencies, if you can look at in India also, how many agencies are available, laboratories are available, which have got the facility for extraction, recovery, and binder test. How many labs are available in India for dynamic modulus test? If so, how are you going around about? That's the issue. We still follow the Marshall method of mixed design. Consistency of wrap materials are other issues. There are specification limitations, processing issues of variability of the wrap, consistent wrap availability, past experience field performance we don't have. So if you look at this field experience, this is one site which I know, which was constructed with a wrap in the wearing course. Within 3 years, it has developed cracks. What is to be done? Now they are laid a bituminous overlay with a glass grid. Now I have a material in this layer. If I want to recycle again, I got a lower layer of a bituminous concrete with a wrap. I have a glass grid layer in between. I got a bituminous concrete overlay with a modified binder. How do I characterize this? How do you recycle a layer which has got a glass grid? These are issues that are to be considered. Quality of the blended binder, wrap binder properties play an important role. The mix will get stiffened. Therefore, cracking will be an issue when in case of aged binder, but check whether a rejuvenator really softens the binder. So there will be a high wrap may affect the binder properties of in an overly stiff mix, may not be resilient, may develop crack prematurely. Therefore, high wrap mixes, even though theoretically it may work in the laboratory, you have to be cautious when you use in the field. So the points to ponder are fractionization, binder content in the wrap, mix design, virgin binder grade, whether it should be viscosity grade or it can be performance grade, plant restrictions if any, and you can use of warm mix as an additive. If so, how will it perform? We propose a revision of the MORTH. I am a member of the task force. What we try to do here is that wrap, we want to be cautious. Amount of wrap is supposed to be 20% or less. The virgin viscosity grade of virgin binder shall be the same if the percentage of wrap is 20% or less. When it is 21 to 30%, the virgin grade binder should be 1 grade softer. For example, if you use VG30 in a virgin mix, VG20 grade for the recycled mix. You can discuss this when you talk about characterization of the wrap binders. If the binder wrap percentage exceeds 30%, viscosity grade of the virgin binder shall be established using a blending chart. Under no circumstances, selective viscosity grade shall be 2 grades softer than the grade that is specified for the 100% virgin mix. VG40 means you cannot use VG10. So these are issues of concern. Why and why not? Perhaps you can discuss further when you attend the lectures on characterization of the binder. We also say that wrap shall be processed such that final recycled mix meet all the specifications like a 100% virgin mix. The wrap shall readily break down at least 95% of the RAP particles shall pass through 50 mm sieve prior to mixing. If not, what? That's another question. Additional crushing sizing may be required if you find larger aggregates. So we say that till we get confidence, we want to restrict the RAP in a recycled mix, restricted to 20% wearing course and up to 50% in binder and base course. But again, if the binder is not properly characterized or the mix is not properly characterized, it will bring a bad name to recycling. Therefore, be cautious when you try to characterize the binder or the mix. At least 5 random samples can be obtained. Determine the blending proportion. You can find that what the binder available in the RAP. Accordingly, you can reduce the virgin binder content when you want to do the RAP mix. So these are something that we have brought in 2023 specification, which will come out here. The second part is coal recycling. As you know, definitely there are a few lectures on coal recycling. I don't want to go into the more detail about the aspects of manufacture of the bituminous stabilized material, but what I would like to say is that it's in between a bituminous material or unbound material and the bituminous material. Asphalt concrete is on one end, which is with a high stiff material relatively, to that of unbound material is in between. So the issue arises at this point of time, when you add binder or a mix consists of binder, will it behave like an unbound material or will it behave like a bituminous concrete? This is where there's a question of debate that has to be done. For example, in a foam bitumen, it is produced by a small quantity of cold water into hot bitumen. The bitumen foams. So we try to find out how when you add water in the air, it foams. When it forms foams, we try to mix the material with the virgin material. You spread some virgin material that is missing gradation, add the foam bitumen, mix, relay it again. The question arises at this point of time is that, will this bitumen stabilized material behave similar to that of an unbound material or a spot welded material, which means will it rut? On the other hand, it has got a high percentage of bitumen. Will it crack? These are something that you have to study. Perhaps you can ask the faculty for delivering talk on BSM to answer this. So coal recycling, let me quickly take you to the field. What we had done, the first coal place recycling project in Chennai Tada Highway. The mixed design specifications were as per Asphalt Academy. We had the major problem that we found is the variation between lab to field. We found the laboratory mix design, brought the sample to the laboratory, tested and found the mix needs about 19% of the crushed dust. We said the cement percentage is 1%. We decide the dosage of water. Everything foaming characteristics, all we studied. But when we went to the code, the lab mixes, when they translated to the field with a different roller passes, we find the density achievable is different. The major problem that we faced was in the variation in the dust, in the gradation of the dust, quarry dust. When there is a wide variation of quarry dust, the mix will not behave as predicted in the laboratory. How do you account this variation? This is something that you have to ask the faculty who is delivering a talk. How do you predict this? I'll show here. When you talk about the variation, wide variation in the quarry dust in the lab, we find that we can study in the laboratory as well. What is the variation of cement content? What will the variation of strength gain? Will there be a variation in the density with the variation in the gradation of the dust? What is the variation if you are not able to foam in the laboratory, in the field as you did in the lab? This is exactly the same problem. We could not maintain the temperature in the field as we maintained in the lab. If so, the mix that you get in the field is entirely different from that of the lab, and hence the problems also will be different. So when you try to simulate this, you find different samples, ideas at different locations. You find there's a wide variation on the compaction with the variation in the blending variation because of the gradation variability of the dust. You also find that increase in ITS, adequate strength of 72 hours, limited effect of the ITSA, some of the parameters like glows increase and decrease detrimental because of the dosage of the pressure dust. If you look at the temperature, we could not maintain the temperature as we did in the laboratory. With the result, ITS values also vary. So the sensitive ITS test, variation one parameter, keeping other constant, cement control and its effect. Laboratory and field procedure is something that needs to be studied when you want to model the performance of the coal mix. We try to study the performance of the field. So I always go from field to lab. Different NDT tests were used. The pavement seismic performance analyzer was used. We tried to find out nearly 300 tests were carried out. Non-nuclear density gauge was used to find the density. AICTE-ATAL was used to find binder content. What is that finally you try to find? What you try to find at the end is that as you move offset from the median, the density value widely varies. Remember, in the laboratory, you get one density, maximum density. You say that optimum binder content or optimum moisture content. But in the field, when you go, you can find a wide variation in the density. You'll find that at the freshly compacted and post-cured, the mean density as well as the standard deviations widely vary because of construction aspects. Do we consider them in the laboratory? No. The proof of the pudding is in the eating. How do you account this variability in the construction in modeling the performance is something that has to be explored. Even find the density variation along the lengths, across the widths. You will not get the uniform density. That is why you find cracking in some location, now cracking in the adjoining 10 meters away. How do you account this variability in modeling? You can characterize the binder separately, mix separately, but how do you account the variability in construction in characterizing the binder properties and the mix properties? The binder that you get in the laboratory may be different from that of the binder that you get in the field. The mix that you produced at the site and constructed a different density will have a different modulus. Similarly, you find the density variation across the section at 50-meter intervals. Wide variation will be there. So if you took a grid, study the density variation along the length and across the widths, we find that non-nuclear density gauge density values widely vary. Do you consider this? That is the question. So if we also use the PISPA, try to find out the seismic modulus, you find again the seismic modulus widely varies at same chainage, it widely varies. How do you account this variability from the lab studies? This is $1 million question that has to be answered here. Even along the length, from the median end, if from one end to another, from 0 is one end to the 7 meters width of the pavement, you find wide variation in the modulus values. You can bring a one mix in the laboratory field, do your dynamic modulus test in the laboratory, and then climb and you can predict the performance, but that doesn't work. How do you account this variability? Mix is the same, mix design is the same, but the modulus values are different. How do you link the laboratory modulus to the field modulus? That's the question. Similarly, density measurements also vary. Modulus value also varies. So we find that there's a wide variability between the lab and the field. Therefore, be cautious before you make tall claims that this will work and that will not work. So for the core test, we find there is a wide variation even in the density with the top, middle, and the bottom. Bottom slice and two halves, you find there's a variation in the air void distribution. There's a variation in the ITS value between the top and the bottom. We get only one number in the laboratory. How do you consider that? Because field compaction is different from that of the lab compaction. Even when you find the dynamic modulus values, we find the dynamic modulus values of field codes are different from that of the laboratory codes. Because the equipment that is used in the field is different from that of what we use in the laboratory. You may get a higher modulus, but can you consider this modulus in pavement design? That's the question here. So we find the ratio between the seismic modulus and the dynamic modulus, and we find that the modulus values again varies at different stages of the binder, the rack. We find that when you consider 800 MPa as the modulus, the pavement fails. But when you consider 1050 MPa, it passes. So there is a wide variation of modulus. Which modulus should be considered in the design is the question here. Durability, when you talk about this, it's a non-continuously bond-based material with partially coated aggregates above the size of 300 micron. So there are flexible spot wells. Is it a bituminous material? Will it crack? Have we studied? But if you look at the studies carried out in India recently, it gives a modulus value of 2260 MPa, density of 97 to 102%, GM of 2.4. So it behaves like a bituminous layer. If so, you should study the BSM material for crack. Do we study? Has anyone studied the fatigue behavior of the BSM mixes? If so, what is the allowable strain value for a BSM mix? Volumetrics is another issue that has to be studied. ITS values are rate and coefficient strength, which are used to find out the moisture resistance. It needs calibration using accelerated pavement testing. Middle guidelines on the gradation, binder, active filler also to be considered here. We find here from this paper by Jenkins, you find the wrap percentage varies, the voids vary as high as 16.6%. Is it a bituminous layer or is it a granular layer? Is something that needs to be addressed here. In the proposed specifications of MORTH, what we are saying is that material to be recycled shall be treated either with emulsion or foam bitumen. They can be granular material. The quantity of the fresh bitumen emulsion typically not to exceed 4%, and foam bitumen shall not exceed 2.5% by mass of dry aggregate. Cement content in the range of 1 to 2%. Percentage of bitumen stabilizer shall not exceed the percentage value of ratio of binder to the cement percentage shall also be greater than 1. Compacted thickness shall be around 100 millimeter, not lower than 100 millimeter. So what we need research is restriction on the use of certain types of wrap only for ideal type of asphalt mixtures. Can wrap form any one bituminous layer? If have several layers of bituminous pavement, layers which have got different binders, how do you characterize them? Limits on the regenerating oil, it can be bio oil, it can be any of the oil that can be used. What is the choice of oil? How do you know that it rejuvenates the binder? How do you consider the performance of aged polymer modified binder from wrap and its compatibility with the normal paving grain? Influence of fluctuations in wrap characteristics, how do you model it? Applying rules relating to the final binder properties with a new and old binder, specialized binders when you try to use, how do you form the rules? What is the allowance of wrap consists of natural rubber modified binder, rubber modified binder, and polymer modified binder? Structural design rules that are used for wrap may not be valid like virgin mixes because of binder and its variation in properties. So relate theory to practice, learn from field, and then go to the model, go to the lab from the field. So summary, lab tested material property and the consequent design vis-a-vis build material property. This should be used as an input in the design and predict the performance. So you should try to validate the laboratory results. Laboratory results are far, far away from reality. Construction translate the design into a reality. Lab test as well as APTF do not simulate the field conditions of actual traffic, climate, environmental conditions. Field performance is the key as it considers in situ construction quality. Solution, what I would suggest is that come from field to lab. Try to go to the field of any section that has been constructed with wrap mixes, study the properties. Then what you try to do is that I need a performance. How is it performing? If it's performing, what was the rehabilitation that was adopted? Coal, in situ, central plant. What are the binder characteristics? What are the mix characteristics? What are the models and the value? If I have to get this performance, I need this technique. This technique works. Okay. If so, how should I construct it? How do you reduce the variability? How do you consider this variability in mix properties in the design process? how do you consider the material property that will give me the strength that will also give me the performance. Therefore, reverse engineering is what I would recommend. Instead of going from lab to field, come from field to lab. You will learn many things. You know theory does not work in the field, and you not know why it works and how it works, but it works. So accept the reality and try to modify your thinking on as how the binder is to be characterized, mix to be characterized, and predicting the performance. Models will work in computer in the laboratory, but in the field, generally they do not work. So if your research findings show that high RAP works, definitely we will consider in the IRC in the revision of the course. So I would like to acknowledge the number of papers which I consulted for this presentation. You can go through this. I have already shared this presentation. So thank you very much for the opportunity given. I think I'm 30 seconds late. Thank you very much, Thushara and Asha, for inviting me to share my thoughts.
Now, the floor is open for queries.
Any questions? For any of the participants?
So the question is, one of
Go
your
ahead.
slides, you shown that a recycled pavement has faced fatigue cracking after 3 years of construction. What was
Yeah,
the
right.
problem there?
Problem is that simple. That's what I have been telling. The major problem is on characterizing the wrap binder, characterizing the mix. So if you fail, you bring some sample, limited sample in the laboratory and test it and then give that this will work in the field, but doesn't work in the field. So now what I am suggesting is that we are now taking the samples from the field, trying to characterize this now. We are doing a post-mortem. Maybe that what we found is that the mix that has been constructed is not as per the specifications. That's why it failed. We have tried to use a glass grid, that also doesn't work. Now look at the cost implication, life cycle cost. On laboratory, everything works, but the field, when you want to translate, it doesn't work. So it's a question of binder characterization and the mix characterization that has failed. Any other question? You can, if you are interested to do a research, you can definitely, test track is available. You can, if you're doing a PhD, if you're a PhD scholar, definitely you can study what went wrong. If your research findings can enable us to understand better, we will also understand and modify that, incorporate in the specifications.
Participants are requested to unmute and raise the queries.
Any other question? Any question in the chat box?
So
I did the question from Joseph, right?
So is there any quality difference between?
Yeah, question is not clear.
So, is there any quality difference between hot milled wrap and hot milled wrap? What's that?
No, hot mixed wrap is what you do in the laboratory.
Sorry, sir. The question is there
Cold
any
mill
quality
wrap.
difference between hot milled wrap and cold milled wrap?
See, the major difference that we try to find is in the case of hot mixed wrap, we try to extract the binder, try to rejuvenate the binder to get properties similar to that other virgin binder or virgin mix. Whereas in the case of a cold milled material, we don't try to extract the binder. We use only either emulsion or foam bitumen. It will only spot well the milled material. So we are not characterizing the binder in the case of cold mix. That's a major difference between cold mix and the hot mix. Any other question? Is there any special arrangement required to batch mix plant to add a wrap? Yes, it needs modification. Ujjava Solanki. It needs modification in the plant. I think this has been clearly mentioned in Kandal's book, wherein he has mentioned what are the modifications that is needed. It costs nearly about 30 lakh rupees. Because the issue that you should understand is that we do not heat the wrap mixes directly. We heat only the virgin aggregate. These virgin aggregates in turn will heat the wrap aggregates. That is why we are trying to restrict the dosage of wrap. We found that up to 20 to 30% is okay. But higher dosage is also possible if you can heat the wrap mixes to a higher temperature without losing its properties or making it further hard. That is possible if you have a double barrel drums. You can go through the ASPECT website. They have a double barrel drums. I will include that in the, we are now revising the bituminous construction in India by Professor Kandal. So in that, I would like to include in that double barrel drum, it's already mentioned is made, but maybe a better sketch as how a double barrel drum will enable a dosage of higher wrap percentage in a mix without undergoing aging. What qualities we have to do in the wrap aggregates? So wrap aggregates generally, mainly the gradation. So depending upon the dosage of the wrap that you're considering, can you use a cutback bitumen for a half warm or a cold mixes? No. So you can use any mix, but the issue is that what is the function of the binder that you're adding? Is it going to rejuvenate the aged binder, or is it going to spot weld? For example, if it is an emulsion or if it's a foam bitumen, it tries to weld and join the aggregate. Whereas when you use a rejuvenator or use a recycling agent, which can be a case of a softer grade of bitumen, it tries to modify the viscosity of the aged binder. So there is a major functional difference between the rejuvenator and the recycling agent that you want to add. Both are not one and the same. So the catch is that, how do you find that will modify? Will it really modify? What will be the aging characteristics? How long will it last? So you should also see in the laboratory, anything is possible. You can add the rejuvenator by hand or any material process and characterize it. But go to the field and see how the rejuvenator is added to the mix. It is the time that is available for you to mix. Maybe it can be a case of a 20 millimeter milling, 30 millimeter milling, 40 millimeter milling. The window for you for compaction varies from 15, 20, 30 minutes maximum. Within that, will the rejuvenator rejuvenate the aged oxidized binder and then give you a property similar to that of the virgin mix? So these are issues of concern. So generally, we do not use a cutback. Cutback will again catch fire. We don't use it. If we use either emulsion or a foam bitumen for a cold mix and use a softer grade of bitumen and a rejuvenator in the case of hot mix. Any other question?
Good evening, sir.
Yeah.
I am Josina Joseph.
Yeah.
My question is, while we do laboratory testing and all, we are getting the hot milled material. So by the time we get the hot milled material in the lab, there is a lot of delay coming. So will that affect our experiment? That is, while we add rejuvenator and all,
all these tests are to be carried out in the field quality control. So it has to be done in the field, not brought to your lab, your college lab. So when there is a delay in the time, what else? Finally, what you will do? You will find out what the density of compaction. You'll try to do a resilient modulus test. You may try to extract the binder and study as how it has happened. So it's immaterial. Even if it's become harder, you're going to extract the binder and test it. So it's immaterial. But the density of compaction depends upon the temperature in the case of hot mix. Similarly, the water content. So when a cold mix has got a high dosage, high percentage of voids, the issue of moisture susceptibility, durability becomes more important than that of the hot mix. Modulus value will vary depending upon the equipment that you use for compaction. So in the laboratory, I do either Marshall method or a guided compactor. But in the field, I use a pad foot roller. I use a pneumatic roller. I use a conventional steam tire roller. So the compaction process adopted in the field is different from that of the lab. Therefore, lab tests do not actually simulate the field compaction. So you can bring it to the lab and test it, but only because you're going to extract the binder, it is imitated. Any other question?
I'm Anil, sir.
Yeah.
Sir, regarding that non-PMGSY rural roads, no, majority of the rural roads, what kind of a rehabilitation strategy will be adopting for these kind of roads? Because over a period of time, the overlay maybe one or two, 3 times they are getting overlaid, but distresses are more what we see in rural roads. So what kind of a strategy?
So I have been associated with this rural road for the last 22 years by now. So the major problem in the case of all these PMGSY roads or rural roads are that they will have 2 layers of waterborne macadam, or at the most 3 layers of waterborne macadam, and 20 millimeter thick premix carpet. We find the permeability of the premix carpet is much, much higher. There's a stripping, potholes formation, it doesn't work. So when I want to recycle the mix, I'll get only the gradation of a premix carpet, which is single size gradation, which is not fit for recycling. Therefore, only recommendation that I would suggest at this point of time in the case of rural roads is to adopt a full depth reclamation. You mill the old waterborne macadam, you mill the bituminous concrete layer, premix carpet layers, then add cement. That's adequate. I don't think that you need a stabilizer. With a lower dosage cement, a full depth reclamation will work for all the rural roads.
So normally the crust available is sometimes less than 20.
In that case, you can go up. Go ahead, Anil.
In case that can we go with the subgrade, or do we need more virgin material aggregates?
There are 2 cases here. Case 1 is that the pavement whole road would have been constructed over a poor subgrade soil. Number 2, the whole pavement might have been constructed with a poor granular, without or inadequate subsurface drainage. In that cases, even if you provide a full reclamation layer, it will settle. So again, this full reclamation can be done similar to that of the whole mix. Either it can be done in situ or it can be done in a central plant. So whenever there's a problem with the lower layers, with veins, subgrade, subbase, I would prefer a central plant full depth reclamation. Whereas if the lower layers are of adequate strength, you need adequate material for the full depth reclamation. You need some of the aggregates. Definitely when you mill the material of a waterborne macadam, you will not get fines. We need fines for any stabilized layer. Therefore, fines are to be added, cement has to be added, and that will form a good base course. But if the pavement has to be raised, it has to be raised, level has to be raised. Some sub-base has to be provided, we can do that. But what I would prefer maybe is time that we look at alternate material like geosynthetics. For subsurface drainage, we can have a composite drains possible. Geosynthetics can be adopted, which may replace a granular subbase. That's something that I want somebody, you may submit a proposal, we can explore it under NRIDA.
Sure, sir.
Yeah.
Okay, sir. Thank you.
Yeah.
Thank you for the nice presentation, sir.
Any other question?
Sir, this is Shalini.
Yeah, go ahead.
Sir, to add on to Anil sir's question regarding rural roads. Most of the cases when we have visited this rural roads, major problem we find is where only in certain areas where there is overloading. Especially these rural roads are near the crushers. So there, if we do this same, what you were saying, FDR, there also the same, because of the overloading, the problem is still persists, right?
No, when all these cases, whenever you have a cement treated base, you should subject them to a fatigue damage analysis. When you find overloading, these thin 15, 20 centimeter FDR layer will eventually crack. So therefore, my recommendation in such cases may be, as has been tried by Neetu and Vishnu, you can try a cold mix as a base course. It can be a wet mix macadam with emulsion can be used, or you can go in for cold recycling, which will not result in cracking. At the most, it may result in rutting. Nevertheless, you have to design the pavement with those properties. So I would prefer, my bet may be on a cold mix rather than on a CTB in such cases.
Thank you, sir.
Yeah. Any other question?
Sir, is complete curing or breaking of emulsion or formed bitumen necessary before construction of the overlaying layer?
Yes.
Will uncured DSM layer result in failure?
No, when it's a slow setting emulsion, you have to wait till it breaks. You cannot do that before that. It will take time. Curing will take time whenever you have a cold mix.
So do warm mix additives help in soften the wrap binder and act as a rejuvenator?
I think there are a few lectures I can ask them further. I have not worked on that. You can talk. There are 2 lectures on the binder characterization. You can ask them whether it is characterized, it will soften or not. I'm not aware of that. Any other question on the wrap laboratory studies, field transfer? I think it's time for me. I think nevertheless, I'm available. Maybe that later also, in case if you have a doubt or any questions, you can post me a question through email. I'll be happy to answer this. If I do not know, I'll ask some expert and get back to you, but definitely you will get an answer. You can. Thank you very much, Thushara and Asha, for inviting me to share my thoughts.
Thank you, sir.
Yeah.
I invite Dr. Ashlada R, Professor and Center Coordinator for FDP of Civil Engineering Department, to deliver the vote of thanks.
No thanks for this lectures and all. Go ahead, Thushara.
No, not of just thanking you, sir. It is always a pleasant experience. Let me on my video also. That will be better. Okay.
I want to tell so many things.
It's always a pleasant experience listening to an experienced academician, a renowned consultant, and an established researcher like you, sir. And you touched the whole gamut of issues related to this particular topic. Starting right from the issues related to the construction, the design aspects, and those related to the rejuvenators, sharing the experience from across the world, and also enlightening us related to the proposed aspects which are coming in the upcoming more guidelines. Thank you so much, sir, for all the efforts you have taken. Thank you.
Thank you very much. I think the link is the same, right? Whenever I have interest, I can join, right?
Okay, sure.
Yeah. So that I can also learn something from experts. Yeah.
Okay, that is your humility, I should say. Okay.
Thank you very much. Yeah.
Thank you, ma'am. Next, I invite Thushara V T, Assistant Professor of Civil Engineering Department. She obtained her post-graduation from IIT Madras in 2008 and is almost in the finishing stage of PhD thesis from her alma mater, IITM. She has been working as a faculty in Department of Civil Engineering at various government as well as aided institutions under DTE Kerala for the last 14 years. Her research interests include bituminous mixture characterization, hot and cold bituminous mixture, analysis and design of pavements. She has several research publications in international.
Hope my video is clear and I am audible.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Is my slide clear?
Yeah, go ahead.
Okay. So I will take the next half an hour to just go through the various aspects related to recycling. I will take from Professor Veeraragavan sir whatever he has explained. He has almost covered everything, but I will just connect it to how we have placed it in our various sessions. So the presentation is basically like the structure is basically I'll have the introduction and I will cover the laboratory phase of related to the recycling as well as the construction phase and the need for the academic industry collaboration. So the course is basically framed with the following objectives. So we have objectives specifically for the practicing engineers as well as for the academicians as well as research scholars. The practicing engineers should be, by the end of this course, they should be able to do the mix design for hot and cold mix recycling and to do the structural design of RAP incorporated layers. And they will be aware of the best practices of RAP management. Now, the various best practices for the construction of RAP will also be covered by the various, will be also clear by the end of this course. Now, for whoever is in the academics and whoever is doing research in this particular area, they will be identifying the various complexities related to the material characterization of both hot as well as cold cold mix, and the different aspects of the RAP mix design compared to the regular mix design will also be covered, and the intricacies related to the various possibilities like the formed as bitumen emulsion, etc. will also be clear, and we can also come up with strategies to account the variability of RAP in the design process. So with that, so this is what this is. I'll just for an introduction slide. So this is recycling. Already you are now well aware of the recycling process. So basically, after this service life, we are using these milled surfaces for it will be reused for the various layers. Now, so let us just speak into the history of recycling. So it was became popular in around 1970s because of the high crude price. And the first reports related to recycling was published by NCHRP in the year 1978 and 1980. However, the super pay mix design, which was released by the late 90s, did not provide the guidelines to include the RAP in the HMA. And since because of that, it has not much become popular in those area for in the mix design. And the inclusion of RAP in the super pay mix design was incorporated in the NCHRP Research Digest 253 released in 2001. And most of the guidelines limited the RAP usage to 15%. That is because of the high variability as well as the high fines content. So, and also there was no incentives given to the construction whoever is in charge in constructing that, because and because of that there was not much progress in the implementation stage of the recycling. Now, however, after 2006, the scenario changed and there is more emphasis on the green technology. So from there onwards, we can see a lot of literature related to the recycling of the pavements. We can see guidelines from the NCHRP reports are there. Then there are guidelines from the South African guidelines, Sabita guidelines from the Asphalt Academy is there. And in our Indian guidelines have also introduced the inclusion of RAP for both hot mix as well as cold mix recycling. So with that, so the various the scenario of recycling in India, specifically in India, related to the specifications and other aspects will be covered in tomorrow's first session by Professor Sudhakar Reddy of IIT Kharagpur. Now, let us just go again to what exactly is RAP. So basically, it has the RAP aggregate as well as the RAP binder, and the RAP binder is basically will be is an aged binder, and that aging will be dependent on the climate, the service life, the amount of penetration and other aspects, as well as how the thickness of the RAP binder in the RAP aggregate. So so there will be variation related to that, and we have to deal with that the current state of RAP binder so as to incorporate it properly in the mix design. So based on the various technologies, there are different types of recycling as discussed by Professor A.V. sir. There is the recycling can be is based on the location as well as based on the production temperature. Based on the location, it is in place as well as planned recycling. And based on the production temperature, there can be cold recycling, half warm recycling, warm recycling, as well as hot mix recycling. Now, what we are focusing further, the way forward is to know whether we have to consider the. So this query was also posted in that chat box, whether we need to consider the mix design containing wrap differently, or it can be the same. And what is the practical upper limit for the wrap content? So as I mentioned, it was earlier, it was limited to 15%. Now the codal provision is up to 30%, but up to what percentage we can go up to increase with the wrap content? So that we have to explore further on that. And if at all we are not, ideally we need to go with 100% recycling. And suppose we are not, like, there are some roadblocks or challenges in increasing the wrap usage. So that also we have to explore further on that. So for that purpose, we have to go a little more deeper into the details of what exactly is happening when we go with different methods like the cold mix, form stabilization, etc. So we should have a closer look into the internal structure of what is exactly happening for the various technology, and what exactly is happening related to the volumetrics, the air void distribution and all. Basically, there is a concern like when we go for the wrap mixes, the air voids are found to be more in the higher side compared to the regular HMA. So what is exactly happening over there? So such aspects have to be explored further. And the intricacies related to the phase diagram, as mentioned earlier, the specific gravity of the wrap material, etc., how to incorporate all those things have to be studied further. So some of these aspects will be covered in this tomorrow's talk by Professor Murali Krishnan of IIT Madras. Now, so the next what we need to understand is, so this as mentioned in the keynote address, coming to the hot mix recycling as well as the cold mix recycling, we have to come up with certain assumptions. So there can be, so what is the residual binder after the hot mix recycling? So there can be different scenarios. There can be a black rock scenario, or there can be full blending or partial blending. So what is exactly happening and what we are assuming, so whether it is correct or not. For example, if we are assuming full blending, and if suppose the wrap binder is acting as a full black rock, it is not activated. So what will happen? How will the mix behave? So there are aspects related to that we need to understand. And so normally the scenario is generally the partial blending, and how to identify such aspects to be covered. Then normally in cold mix recycling, we'll consider that is black rock with no binder activation, because we are not heating it. So such as now, like coming to the, so depending upon the amount of activation, so what is the target binder grade that we are expecting, that is to be understood, and accordingly we have to provide the fresh binder. Okay, so that depends upon the amount of the wrap percentage that we are incorporating in the mix. So as per the guidelines available right now, as per the NCHRP report, so it is connected to the percentage of wrap and the recovered wrap grade. So normally like the amount is limited to 15%, because we don't have to extract the wrap binder and have to characterize it. And if we are going further beyond 15%, we have to extract and identify the recovered wrap grade, and accordingly we have to apply come up with the virgin binder grade to achieve the target. So such aspects will be covered in the wrap binder characterization in day 3 session 1 by Dr. Nivita of PSG Technology, Coimbatore. Now coming to emulsified cold recycled mixes. So how to go about with the mix design? So what are the various ingredients related to that? How for the emulsified cold mixes? how well we have to identify the various components. So such aspects have to be dealt in detail. And coming to cold mix, so as again it is discussed earlier, so how to characterize it? So it can be like it will be acting, whether we have to characterize it as a granular material or it can be characterized as a bituminous material. So that is something we, as sir mentioned, it is a talk of debate, and we have to identify so how actually it is behaving. Accordingly, we can use it either in the surface layer or in the base layer. So so we need to, what are the test methods to characterize the material to depending upon the property of the behavior of the ECR mixes have to be explored further. And we need to basically achieve a balanced performance in terms of the fatigue as well as rutting performance. So mostly in all the bituminous mixes, there is a tight, we have to attain a balance. That is the most challenging thing. It may perform better in rutting, but may fail in fatigue. So how well we have to achieve that balance between fatigue and rutting performance has to be explored further. So for that, what are the different test protocols we have to adopt, especially for emulsified cold mix recycling and all, which test protocols we have to adopt, such the typical material characterization test protocols has to be explored further so as to correctly identify its property. So these aspects will be covered by day 3 second session as well as day 4 first session by Dr. Padmarekha of SRM University, Chennai, as well as Dr. Neetu Roy of MBCET, Trivandrum. Now coming to the various additives, whether it is a rejuvenator as well as warm mix additives in hot mix recycling, there are a lot of issues related to the issues as well as challenges as well as scope for incorporating such technology in the mixes. So for I understand, to have a better understanding, we have to get little more in detail of the various rejuvenator options. What is actually happening when we are adding a rejuvenator or a warm mix additive? So that has to be studied further. So this will be covered by Dr. Asif Ahmad from Ingenuity Group, who is in forefront of implementing many real life projects in India, and also by Dr. Ashalata, our course coordinator, who she will also share the experiences from the student project of CET. Now, so next step is we need to do a real mix design process. So there are various stages involved in the mix design process of whether it be a hot mix recycling as well as a cold mix recycling. So I will be discussing some of the aspects. We'll do a so there are many sessions in few sessions in the offline session related to the mix design part for hot mix as well as cold mix. So the intricacies of wrap mix design will be covered by 2 sessions by Professor Murali Krishnan of IIT Madras, and I'll be doing a real life a full design example of a hot mix recycling in session 7-2, and we have a presentation by Srijit GH, who is a Deputy Director of Kerala Highway Research Institute, who will be talking about the implementation of laboratory mix designs in the field. So these are the offline sessions related to the wrap mix design. Now coming to the form mix technology, so there are different options related to that. The specific technology has to be explored, and the mixer evaluation and other like construction aspects have to be explored further. So we have 2 sessions specifically on bitumen stabilized material as well as material. By one is from the industry by Ajay B. Pujari from the Rinjan India group, who is in the cold milling product manager. He will be sharing the experiences of the recycled projects which is actually carried out, as well as the foam bitumen technology. Now, another presentation is by Dr. Nivedya. She is working on as in San Diego Association of Governments in USA. She will be joining us online to present on the building sustainable road infrastructure using formed bitumen technology. Now coming to the performance, what about the laboratory performance when we are incorporating RAP in the mixes? So whether the inclusion of RAP will result in more stiffer material, whether the modulus will increase, whether the fatigue performance will increase, will it affect the durability? So there are many aspects which can be captured in the laboratory stage, and this will be discussed by some of the PMRF student presentations. They will be presenting their findings related to these aspects. This is also again in the offline session. Now, so coming up with the how much RAP has to be used. So now coming to the construction phase. So there are limitation for the use of RAP, the implementation of RAP based on the plant restrictions as well as the processing related to the RAP. So there are concerns on how to process the material, whether to fractionize it or not, how to do the stockpiling, how to store it, how to go about the inspection, test plans, auditing schemes, etc. in the actual construction field. And so whether we can allow to permit the RAP which is having some minimum binder content or maximum, we have to limit the maximum filler content. So such aspects related to the construction will be covered by specific aspects will be covered by different speakers. So we have so from the different options from a permanent owner perspective, which all options will be a feasible or the viable option for different projects will be discussed from Indian scenario as well as international scenario. We have speakers who will be presenting such aspects. So again, there are I have seen the queries related to when to add the rejuvenator. So the processing of the RAP and how to heat the aggregates, how to heat the RAP aggregates. So such queries related to the construction can be discussed, both related to hot mix as well as cold mix recycling. Like when can we go for a wearing course, how much curing is required. So such many of such aspects will be covered by the experts. So we have quite a lot of presentation by experts who are working specifically in the implementing side. So we have a presentation by Dr. Stephen Chalmers from the Ingenuity Group, who is the Asia production head related to the recycling projects. And that talk is on Saturday, second session. And for the convenience of his timing, we have slightly changed the schedule from the session will be starting from 9 to 10. So this particular session. And we have other sessions by Professor Anjan Kumar from IIT Guwahati, Professor Samson Matthew, who is the director of NATPAC, and we have presentation by Srijit KM from KHRI, and we have also a presentation from Arpan Ghosh, who is the principal consultant of VR Technique Consultants. So all these sessions, mostly except these two, mostly the sessions are in the offline. 2 sessions are in the online period and 4 sessions are in the offline period. Now, coming to the variability. So as I mentioned earlier, the lab is limited. The lab amount is limited mainly because of the variability. So there can be variability on the gradation as well as on the binder content. So this is the same from the stockpile. When it is taken on the same day, we can see a variation in the gradation as well as the binder content. So how well we can deal with the variability related to the RAP in the mixed design as well as in the processing. Such aspects will be covered in the offline session first day, session 8 by Dr. Arvind Swami of IIT Delhi. Now, we have to be aware of the various documents related to the recycling projects and what are the specifications of the various countries. Then what should be the order of the SOP related to the construction practices. Such things will also be covered by the different sessions. And so with that, next is that we have to, so this particular course has a spectra of participants working from the coming from the industry as well as academia as well as from the research group. So so there is a scope for a public industry working group, and for the funded as well as coordinated research as well as demonstration projects further on that. So we have got a good support from the various industry as well as from the government side to start up with the various demonstration projects. Now we have to so what are the policy decisions? So next is that we need to come up with the policy decisions to incentivize the sustainable practices. So that is the next stage. So when it comes, automatically this the RAP related projects will come to implementation stage. So so this aspect related to the different aspects related to the current challenges as well as the various future research ideas will be presented by Professor Animesh Das of IIT Kharagpur. Again in offline session on Thursday, the day offline session day 4 and day 5, that is session 12-1 and 14-1 by Professor Animesh Das of IIT Kharagpur. So this is the panel of experts we are presenting for the course, and with that, so let us work together to push these new technologies for a better India, and hope this course will be beneficial for all the participants. So with that, let me wind up this presentation, and the next 15 minutes we'll keep it open to the participants to raise the specific concerns related to the course. Thank you.
Thank you, ma'am, for sharing your knowledge and giving us an opportunity to listen to your words. Participants can raise queries related to the course.
Thushara, they will have questions only after the lectures. We only showed the contents of the lectures. So they may ask for the,
yeah, but there can be queries related to their accommodation course and the general structure. So such queries we would like to take up now, so that it will be clear for the participants.
Good evening, ma'am. In case we miss some of the sessions, will the records be made available to us?
So actually there are two groups here. So there like people who are from far places who would like to gain knowledge from this specific topic, but they are not unable to attend the offline session, and we were not able to make them as a registered participant. They will be listening the online sessions, and suppose in case they are not able to attend also, the ATAL, according to the ATAL program, we have to upload the link of all the lectures in their platform, so that will be available on a later stage.
Thushara, will you give a certificate for those who are missing the lectures?
Certificate for so for the among the registered participants, according to the AICTE norms, they have to have 80% attendance.
Okay, that's clear. Yeah, so Katya. Sukanya wants to talk something.
Any other queries?
You are talking about this policy decisions about incentives for this coal mix recycling technology. Both sides. There's some noise. Mute.
Yes.
Yeah. I think the issue that I think I would like you to have some panel discussion with somebody from KIFB. Maybe Vijay Dasa, somebody you can call.
Okay.
So somebody from PWD, so that they can tell us how to introduce this in a large scale in KIFB and Kerala. What incentives they can give, what policy decisions are to be taken to encourage use of RAP.
Okay.
So we should know from their end. We are doing some laboratory models, like, studies, develop some models and say that you can add 50%, 60%, we are telling. But will they adopt? Will they take a risk on the performance? Or will somebody who are designing, I would like to ask somebody who is also talking about these models, they are talking about laboratory, will they give a guarantee that their mix will perform in the field? If so, they can also be taken aboard. And with KIFB, we can also take up projects with a higher RAP content. So policy decisions, you have to bring somebody from PWD, KIFB, or KHRA or somebody.
So there is participation from KIFB. If you PWD,
that participation, say generally participants will be the junior level officers who cannot take a decision on the policy.
Okay.
So I am specifically talking. Yeah. Go ahead.
Also, we have informed about this course, given the particulars of the course to the PWD minister, and he will be giving a short presentation, video on of that. And along with that, we'll be giving a report of the outcomes of the course for further implementation.
No, that's different. What I'm telling you is different. You are going to give a report, it will be filed. That will not take life afterwards. So what I want to know is that from the user agency, what is their condition if they want to give an incentive for RAP?
So
the other question which they will definitely ask is that, will the RAP mix be cheaper than conventional virgin mix? First question they will ask. You should be ready with that answer. What is the break even when I have 10, 20, 30, 40, 50% RAP? What are the benefits in terms of the cost, initial cost? Life cycle cost wise, you can prove, but they are interested in the initial cost. What are the plant modifications that are needed? So once you, and then will you guarantee on the performance? So once this comes into picture, then perhaps we can take it up. So before you want to give an incentive, we should be clear whether what we preach will work in the field or not. So if you can listen to them, perhaps we can fine tune to meet their requirements.
okay, sir. Okay, sir.
So ideally, I would like to ask you to interact with Vijay Das. Or you have from PWD who is in charge for the Madras rehabilitation. Call them for some discussion. You have got one session free now, one day. You can call them for some panel discussion. Call them. We'll interact with them, with the some of the vendors. They're also here. User agencies are here. Academicians are here. Let them share, clarify the thoughts. You can think of that. And in all cases, in your presentation, you had a mention about that. In all coal mixes, you need a dense bituminous concrete wearing course. This coal mix cannot serve as a wearing course. Because you also admitted that it has 15-16% voids. So it cannot serve as a wearing course. That is the limitation of that. So definitely in Kerala, I personally feel you have to adopt recycling in a very large scale. But issues or concerns we should discuss with the user agency.
Okay.
Any other question for anybody? Yeah. Any question for anybody?
A very valid point, sir. We definitely.
Now, we all do theory because that's why I always tell our object is to publish papers. We can mix anything and publish papers. That's different. But the field in the requirement is different. You talk to them first.
Yes.
And then do your research to meet their requirement.
Okay. Then only these kind of courses will be fruitful.
Yeah.
Yes. Sir.
Somebody who can take a decision.
Yes.
They should be there.
Okay.
Yeah. Finally, what I need is that at the end of this 2 weeks program, it should be beneficial to the state of Kerala.
Okay.
It should not file as some report conducting some course and then over. No. You should find place on the ground.
Okay.
How to do that? We had work back.
So we'll directly go and meet the top officials in KIFBI.
Yeah, you can. Yeah.
Within 2 or 3 days.
You can talk to MD and then call the concerned people.
Okay.
Yeah, even Murli is there. LS Murli is there.
Yes.
Yeah, you can call some of them from PWD also. You can ask KHR also. You can ask them to participate. We can academicians can tell us how it will work.
Okay.
So CUBE participants are there. So we can have a good interactive interaction, which will enable them to adopt this technology in Kerala.
So the point well taken, sir.
Only then this course will be found useful.
Yes. Exactly.
Otherwise, if academicians talk something, research point of view, modeling it, no.
Yes. So how it is going to be beneficial to the state?
Yes.
And how the state can take it on a large scale.
Yes. I would have expected the PWD minister also to talk so that we will know his requirement.
Okay.
Yeah.
We'll see. Okay. Sir.
Yeah.
Okay.
Till 2 weeks. Yeah, please.
Sir,
there's a question also there. I think somebody at the Rajikot Municipal Corporation, I think I don't know who has asked the question. How to prepare a tender document. Plant owner asked how to add the into the plant. I think Ujaval, I think now you can get it from Atasi Das. Atasi is from GR Infra. They are adding up to 50 to 60% wrap in their plant.
Okay.
So the plant has been modified. I can give some references to the agency from Amman who have modified the plant. They can tell you the cost economics. Okay. Atasi will say as how they mixed in the field. Okay. They are constructing, in fact, a perpetual payment.
Yes.
So we will know from them. We can even Atasi also can be invited. They can throw more light on the implementation point of view.
Yes. Okay. I think in this journal, the paper is published on perpetual payment in January.
That is true, but according to me, that payment will fail, according to me.
Yes.
That's a different type of story. Other than that, we are doing something. One is lab, and this one. So we have to see as how it will function.
Okay.
Yeah.
Okay.
Yeah. Any other question for anybody?
Sir, region can help us to how to recycle the pavement and.
Yeah, definitely that can be. They adopt mainly cold recycling, especially cold in-place recycling.
Okay.
So CUBE, I think they are experts who are talking here. They will talk about central plant recycling also with emulsion. That's possible. Cold, I don't know why they are not invited. They could have invited Shegel from the hot in-place recycling. So he brings some rejuvenator. He says it rejuvenates. But whether it rejuvenates or not, I have seen the section is performing well. I have experienced, I have observed the performance. Perhaps we also should have one more lecture on hot in-place recycling should also find a place. This is incomplete.
Yes, sir.
Yeah.
We have a presentation on the cold plant presentation.
No, hot in-place recycling is what is needed in a very large scale, because top-down cracking is the most found distresses on many of the national highway payments. It warrants only recycling of the top layers, 30, 40, 50 millimeter. HIR will work. They are carried out between Trivandrum to Gundurpet in Tamil Nadu. Performance has been satisfactory. They are doing many more projects. Perhaps you can listen to them as how they are doing. They will not be able to answer your questions, more analytical, theoretical questions, but practical point of view, what they are doing, they will be able to explain. Maybe if it's possible, somewhere you find a slot, you can request a Shegel to deliver an online talk.
We'll check with the possibility of having.
Yeah. Now, what I finally look at is more of practice, less of theory. Okay, go ahead. Any other question for anybody? Many people are tired. It's at 9:30.
Yes, sir. After the program is scheduled in that way. After the
So why not you start a bit early, 6 o'clock or something, and finish up early?
because the people may be in the traveling phase or something like that. So it is.
They'll attend from office.
This is how they have given the schedule, considering the.
Okay, it's okay. Anyway, we were told now this point of time nothing can be done. Nevertheless, I'm happy that at least 50 more people are still there.
Yes, sir.
Yeah, fine.
As all good things come to an end, so is this session. But we learn and continue to grow. Thank you everyone who have gathered here to make this event a great success. We appreciate the efforts of all sources who have directly or indirectly contributed to make this event memorable. Thank you.
So thank you very much. Yeah.
Thank you for
Yeah.
thank
Thank you, Thushara. Yeah. Thank you, Asha. Yeah.
Good night.
Thank you, sir.
Yeah, thank you.
We're both in the same place now.
Yeah, okay, good, okay. I thought both will be in different houses, your house and her house.
No. We thought we should not have any tension in between. So better to be in the same.
She stays closer to the college. You're
Yeah,
not.
I want to say closer to the college.
Okay, then fine.
Okay.
Okay, see you. Maybe that same link, right? All the days. Okay. Let me see. Let me also learn something in the process. I don't need a certificate, but nevertheless, whenever time permits, I'll see. Yeah.
That's a pleasure.
Okay then. Yeah, thank you.